Cast is now starting. All attendees are in listen-only mode.
Good morning or afternoon, and welcome to today's webinar. Thank you for sharing your time with us. Let me start off by just going over today's format. So we will be taking questions. If you would use the control panel and put any questions that you have, we will attempt to answer those questions in the time we get them. If we're not able to get to your question at real time, we'll have that delayed to the end of the presentations, but rest assured that all questions will be answered. Also, as part of this webinar, we have put out some PDF handouts, and anyone interested in professional development credits, we do have a certificate that's available for you as well. During the presentation, at certain points, we will be asking several poll questions, so please feel free to engage in that way. Lastly, we are dealing with technology. We are using the GoToWebinar platform. We hope there's no interruptions, and we'll do our best if there is any issues that should arise. If there is any issues, you can blame the platform and contact them directly. However, if it runs smoothly, I give full credit to our IT department and our marketing team for having us prepared. And with that, let me start off and just do a general introduction to BERT process. So a couple things with BERT process is this year we're actually celebrating 50 years in business. Certainly not the year we envisioned with all things COVID and the challenges that we face. However, when I do look at this year, I hope it reconfirms that we're a company that embraces challenges, cares for the well-being of our employees, and has the fortitude to overcome any challenge that we face. So as a company, we've come a long way from our early days with locations across North America while specializing in all things fluid handling. As a global distributor, we focus on products throughout the fluid process system. Some of these products include general piping equipment, pumps, instrumentation, flow level and analytical, control equipment, as well as skidded systems. As a system integrator, we manufacture systems that handle all fluid types, from corrosive chemicals, rainwater, industrial wastewater, to high purity water systems. There isn't a fluid stream we don't handle. BPE has a team of mechanical, electrical, and chemical engineers on staff that can aid in system design, product management, CAD design. Our highly skilled fabricators specialize in plastic, steel, welding, as well as general assembly. BPE also has a UL 508A approved control panel shop and a staff of PLC programmers. All aspects of manufacturing is handled in-house by our capable staff. Regardless of your location, BERT process equipment has people across North America willing and able to support you and your next project. So let me take a second just to introduce myself. My name is David Carson. I am the National Sales Manager for BERT Process. I've been in the fluid handling industry for over 20 years, and I've been with BERT for over 16 wonderful years. During my time, I got to meet great people. One of those individuals, Leah. I've attended several of his trainings, and I'm glad that he's here today to do a presentation on flow instrumentation for you. A little bit about Dave. Dave's been in the industry for over 36 years. He's been a leader in flow analytical instrumentation and process automation. Again, I've had a pleasure to attend several of his trainings, and I'm certainly believe that he'll do you a great service by educating you on all things flow. And with that, I would like to welcome Dave Valaire and thank you again for participating in today's webinar. Dave?
Well, thanks, Dave. Thank you very much. And hello, everybody. Dave, if you could advance to the next slide, that'd be great. One more. Okay, so we'll be going over the Paddlewheel flow sensors first. It's kind of the bread and butter of the Signet product line. It's been a sensor choice of ours for going on 50 years now. The Paddlewheel sensors, they come in a couple different models. The red cap one, like you see in the picture, is a 515, and then the one underneath is a blue cap, and that's a 2536. So these sensors come self-powered or powered. They can measure as low as down to 0.3 feet per second with the powered unit, and with the 515 self-powered unit can go down as low as 1 foot per second with a max range of 20 feet per second for both sensors. They're compatible for the most part with all Signet brand flow indicators. The 515 is basically for all. The 2536 would be limited to everything but the battery operated, as it's being a powered sensor. It does require a host unit to provide that power. The sensors, as you see, come with a polypro body material and a PVDF rotor and titanium pin. They're very good for light acid duty and caustic applications. We do have other optional materials in case there's chemical concentrations of acid that would be otherwise incompatible with polypro. So we do have those options available, and you know, different paddle wheel rotors and options on that for abrasive applications that may turn up. So they do come in 3 sizes. The P2536 P0 would be the polypro material. The 0 would be for 1/2 through 4 inch line. P1 would be for 5 to 8, and then a P2 would be for 10 inch and above. Both sensors are capable of sensing flow bidirectionally. They can't differentiate with this particular group of sensors, but other sensors we have can. There's 25 feet of cable that are standard with these. However, they can be extended up to 1,000 feet with the powered sensor and up to 200 feet with the self-powered 515. They can either be done in the field as long as they're properly spliced and shrink wrapped with solder and the shrink wrap, of course, or it can be ordered with the extended cable. Just simply contact your Burt Process representative and they can get together with you on providing a special part number for that and availability. They do require Signet installation fittings. They are point velocity sensors. So in order for all the calibration data to be valid, you do need to use a Signet installation fitting for that. The units themselves are designed for clean water-like fluids. As I mentioned earlier, they can be used with other chemicals. Things to watch out for would be the viscosity of the chemicals, you know, if the temperature is going to be consistent. And if there's any changes in the temp which would affect the viscosity, then we'd need to know that. We have a tech staff on duty in California, and of course your Burt Process representative would be able to help you out with that too. Then of course you want to make sure you observe the recommended installation geometries on these, as we'll get to in a later slide. Next please.
Hey, Dave, a couple of questions. Knowing that the paddle wheel sensor using clean fluid, what does happen if solids are in the fluid, or is it a way to detect that solids have actually impacted the flow meter?
Well, one of the things, of course, everybody usually assumes that when they have water that it's going to be a very clean application. And it's usually later down the road that they find out that either by wear or by fouling, that the paddle wheels either have a tendency to stop performing or completely drop out entirely. which could mean that if it's an abrasive material, the rotor and pin can wear out and drop off and end up down in a strainer basket somewhere. Or if it's a fouling material, it'll simply stop and would necessitate, having the sensor pulled out of the fitting to check and see what's causing the issue. But we do have options for abrasive applications, different rotor with sleeves on it, or as we talk about in a little bit, magnetic flow sensors. So one of the options that we have with the flow line of paddle wheels is the 2537. So typically you would get a sensor, an installation fitting, and then some type of indicator on either a field mount or a panel version, similar to like our 9900. However, some applications where display only on the HMI and may not have a need for the extra expense of a display. So in this case, you've got the 2537. Now there are a couple different options. It would be a proportional pulse. So if you're doing any kind of chemical dosing, such as nutrients for fertigation, storage of drinking water, in which you would be adding proportional doses of chlorine. And so you can also use this as a flow switch, for a high or low alarm condition, or as an S3L, which would mainly be an option for our 8900 multi-channel unit that handles up to 6 channels of input, or our most popular version is a 4-to-20 blind output. So this is where I was saying with the HMI interface, and some customers, especially on the OEM side, may not need that extra display. They can choose to get this, and this is pretty much our best seller that we've got going for the 2537 would be the blind 4-to-20 output. They do come in limited sizes. They come as a 1/2 to 4 inch and a 5 to 8 inch. Anything larger, say 10 inch and above, we would recommend that you would go to the 2536 or 515 in conjunction with either a field mount or panel mount 9900. Again, the sensor is basically the same electronics and setup as the 2536, so it's bidirectional on flow sensing. And then as far as the enclosure is concerned, with much of the Signet products, it is a NEMA 4X, so watertight as well as corrosion resistant. Okay, next please. All right, as mentioned, we do have a line of installation fittings. So whenever you're purchasing a flow system, one of the things you want to make sure of is you go over the application with your representative, make sure it's going to be acceptable for a paddle wheel flow sensor, as far as chemical compatibility, fluid viscosity, and so on. And then you'll want to get a material installation fitting that's based on your piping material. So we have everything from PVC to CPVC to metal installation fittings for iron, carbon steel, and stainless pipe, to polypro and PVDF for engineered piping systems. Always make sure that when you're doing a plastic insertion sensor that you get a Signet installation fitting. It helps establish the correct depth so that the K factors or calibration data is valid for this installation. Next, please. All right. One of the sensors that we have in the product line that's kind of a specialized sensor, again, we're a plastics company over at George Fisher, but we do also cater to the metal lines as described earlier with the plastic paddle wheels and metal installation fittings. So the 525 is a specialized sensor that can handle up to 1500 PSI as well as up to 300 degrees F. If you look at the charts on the plastic flow sensors, there's going to be a variance depending on your temperature and pressure, which we have curves in our documentation to show that. But in the case with this particular sensor, it can handle the high temp and high pressure, both at the same time. It is a self-powered sensor, so it outputs a sine wave just like the 5 to 15, but at a lower amplitude. And because it is metal and it takes a little bit more inertia to get it to spin, the low end capability is about 1.6 feet per second and has a maximum rating of 20 feet per second. It is made of 316 stainless steel, and it comes in a couple sizes to fit with a block style fitting for 1/2 to 1 inch pipes. And then for the 1¼ through 12 inch, it comes with more of a tapered tube type weld-on connection for you to put on the pipe. Standard cable length is 25 with a maximum capability of up to 200 between that and the sensing or indicating unit that might be used. Okay, next please. There we go.
We had some issues with the audio, but we should be back now, Dave.
Oh, okay. Sorry about that. Wonders of technology. So, okay. So for those applications, we do have metal sensors, as previously stated. These particular sensors are adjustable. This is our 2540 stainless steel paddle-wheel flow sensor. These are sensors that can be used with an off-the-shelf 1.5 inch female NPT connection. So the user can purchase their own, or again, purchase it through their process. It fits 1.5 inch up to 24-inch pipe. The sensing element on it is also electronically powered, so it will output a square wave signal with low-end capability. Yeah. 0.3 per second, all the way up to 20 feet. Requires a little bit more power, and as with all the other Signet powered flow sensors with the wave, so that if you want, you can use it either with a Signet instrument, which will give a display as well as a 4 to 20 output in most cases, or you can take it directly to a computer that can be scaled that has a high input card. The whole price of the sensor, only the electronics. They come standard with 25 feet of cable, and since they're powered, they can also be utilized with a up to 1,000 feet maximum on the cable. Hot tap, you'll see that there is a longer sensor here, so for those applications where the rotors may need service or cleaning every once in a while, the welcome back, Dave. The unit itself can be placed through a process connection where there's a valve and a close end nipple on top of the installation fitting, which would allow for installation and removal of the sensor should that be necessary. Next slide, please.
Yeah, and Dave, I just want to point out,
sorry.
With that hot tap sensor and going through that full port ball valve, the ease of being able to maintain that flow meter is definitely an important piece of the decision-making process. Unlike the other instruments that Dave talked about, those cannot be removed under pressure.
Absolutely. And this kind of goes into a cost of ownership scenario where, the Signet products are very good value. They're a mid-tier product with very good reliability. We even supply certificates on most of the flow sensors. But that cost of ownership, if you have fouling and you have to take the sensor out every once in a while, now you've got the shutdown time, you're down on production, whereas with a wet tap assembly or hot tap assembly, in this case, you can easily remove the sensor from the line without interrupting the process, do any necessary service, and put it back in, and you're back up and at least reading without ever shutting down the process.
I think we have a video on slides moving forward on showing a unit going through a full bore valve.
Okay. All right, so on one of the slides I had alluded to observe the geometries for up and downstream requirements. Because these are insertion type point velocity sensors, we're relying on this flow profile to be the same regardless of where it's put around the pipe. Now, most Signet sensors, ideally, we recommend away from a 12 o'clock and away from a 6 o'clock position. 12 o'clock can have air bubbles, which are not too much of an issue for paddle wheels. But if the application is found to be not so suitable for a paddle wheel and we need a non-moving part meter like a magmeter, we absolutely want to be away from that 12 o'clock position to avoid any erratic readings that the mag would experience. So that's the main thing. And then the 6 o'clock position would be issues with debris or sediment on the bottom of the pipe. But on our straight run requirements for being after an obstruction and back to the point level measurement, or point velocity measurement, excuse me, we need to have a certain amount that's observed after an obstruction. Most customers recognize, as well as us, that it is quite a big distance, especially on OEM skids. So reducing the amount of upstream diameters after obstructions is usually acceptable, and it's all based on managing your expectations on how accurate you want the system to be. If you're only looking for a breakdown or an open in the pipe or a pipe break, then something like this would be ideal because it will give a sudden output change if something like that were to occur. But for more accuracy, for better readings, close to what you would expect them to be, get as close as possible as you can. This might not be the technology you need in the application like this, but we may have another option for you.
Yeah, and not to be redundant, but I'm going to be redundant. We see it quite often because of the illustrations in the manual show the instrument at 12 o'clock. Entrained air, off gas and chemicals, that can be a huge problem that reduces the performance of the flow meter. So as Dave alluded to, is you do not want to mount the device at a 9 o'clock and have
Dave, I've got a drop off. All right, so one of the things that some of the things that bring benefits to utilizing the paddle wheel flow sensors is there's a very linear, repeatable output. We provide certificates on all of the plastic sensors that you see in the picture. So the 2536, 515, 2537, they do come with certificates on their calibration, and they can be reissued. Just contact the repair department on something like that. There's a very linear, repeatable signal. There's virtually zero pressure drop. They're easy to install and remove, especially on smaller lines. Choice of welded materials for different applications where you might have different chemistries that would require maybe a Poly Pro or PVDF option. Fairly high turn down ratio, so they can go from reading very low to very high velocities. Just be careful that the velocity isn't so much that it would be abrasive on the moving parts, in which case you may want to move to a non-moving part unit. And again, because I mentioned earlier, it's a mid-tier type product that gives very good performance for the money. So it does give you a fairly low cost of ownership. The only limitations that you really see is, you know, it's hard to get a good accuracy spec due to different types of fittings that can be used, and, you know, slight differences in insertion depths. Moving parts can always be an issue, especially if you find that an application that was supposed to be clean was not as clean as it should have been, and it results in wear of those moving parts. It does require long straight runs, as we just pointed out. And with the exception of the adjustable sensors, you do require specific fittings for a given installation. Next. All right, which brings us to the magnetic flow sensors. So we have the 2551 line of magnetic flow sensors. So in the lower right-hand corner, you're going to see one that is a blind version, or just a straight yellow cap on top. And then next to it will be a display option, which we have available. Just to give you an idea, the blind version and then the version which outputs in that similar package, either a frequency or S3L signal. Those are our more popular movers. Because there's no moving parts, these operate on Faraday's law. They can measure down as low as 0.15 feet per second and up to 33 feet per second, which is probably beyond most applications and capabilities on plastic pipes, but we can still meet that if necessary. We've even been tested in fire truck applications with these. They do fit into standard installation fittings. So if you do run across issues where the paddle wheels either wear too often or get fouled, and, you know, the application isn't exactly what you thought it was supposed to be, this is a very good option. This will fit in the same installation fitting, and as long as the sensor is powered, or excuse me, the indicator is powered other than a battery operated unit, it will actually fit in to the same installation fitting, utilize the same wire as the previous sensor that was in there, and would only necessitate a recalibration with the new K factor for the 2551. So these do come with an S3L or frequency output. The other option would be a blind 4 to 20, so much like the 2537 that has that that option of being, excuse me. So the 4 to 20 is a unit that is, again, the blind offerings, just like the 2537. They can be configured for both forward flow as well as reverse flow. So as mentioned earlier, these particular sensors with the S3L output feeding into an indicator will actually show plus and minus flow rate on the indicator depending on direction. And then on the 4 to 20 version, you can actually see flow in the forward direction and then flow in the negative direction, with the 4 to 20 being spanned with a negative value at 4 milliamps and a positive value at 20 milliamps. Chemical resistant materials, just like the paddle wheels. So the standard version is polypro with stainless electrodes. We do have PVDF and titanium and Hastelloy C electrodes with the PVDF as an option. They do come in sizes for 1/2 to 4, 5 to 8, and 10-inch and above. And the main thing here is they do require a conductive fluid. So any hydrocarbons, oils, things like that could produce issues for this. And once you get down into the lower conductivity waters, 20 microsiemens is basically the limit for all Signet magmeters, so we can't go any lower than that. And just like the paddle wheel sensors, because these are point velocity sensors too, even though they're using magnetic technology, these need to be utilized in Signet installation fittings with the same recommended installation geometries.
Hey, Dave, with the clearer advantage of no moving parts compared to the paddle wheel sensor, where would you choose a paddle wheel sensor over a magmeter?
Well, as mentioned, when the liquid gets to be a little bit more on the verge of being resistive water or low conductivity, this is where we prefer it, much like on RO systems. So you can utilize mags on if you wanted to measure the concentrate, but for like feed and permeate lines, paddle wheel is probably going to be a better option. Usually one experience much wear on a feed line, and then on the permeate where the water quality is much higher and lower conductivity, then something like that would be a better option for a paddle wheel.
Thanks, Dave.
Okay. We also have the insertion option. So we've got the 2552, which is the metal version of the Magmeter series. This one, again, comes either in a direct installation or in the longer version can be utilized for hot tap / wet tap type installations. It does fit line sizes anywhere from as low as 2-inch all the way up to 48-inch. Same bidirectional sensing capabilities as a 2551. And again, just make sure that the fluid being measured is conductive and is not containing any oils or substances that could coat the face of the electrode. And being a point velocity sensor, you want to make sure you observe the installation geometries. And one other note that you want to make sure to be careful of is you'll see that you've got a fitting, a nipple, a ball valve. As you get into the larger sizes, you want to take care that you don't go too high in the stack height so that you also can assure that you get the 10% insertion depth into the larger pipes.
Yeah, I want to throw, we do have an example where this device worked well in a client who was operating a food process, had fats, oils, and greases, and those fat, oils, and greases will coat, to Dave's point, the probes. The nice thing with this unit was they were able to go on a regular basis and actually clean it. And when you compare this device and the ease in which we can clean it in those applications compared to a competitive type of equipment, this was actually a better overall cost of ownership than competing technologies.
Exactly. I mean, we actually have run into that more than once in the past where the overall cost of ownership, even though full bore mags might have been a better option for accuracy purposes, these units where the accuracy usually isn't needed as high, and these are 2% of reading, by the way, of accuracy, the customers realize they're going to have to pull them out and clean them. And with that amount of labor that's being saved, basically pulling it out, knowing they're going to have to clean it, wiping it down, putting it back in without interrupting service, and having one guy instead of a few to pull out a full bore mag, definitely a big advantage here for cost of ownership. Okay. We go to the next slide. Okay, so some of the limitations, and I think we went one too far. There. There we go. All right, so insertion mags, the benefits, of course, there are no moving parts, very linear signal, virtually zero pressure drop, easy installation and removal, as Dave Carson just pointed out. You've got a choice of wetted materials on the plastic. You get a very high turn down ratio on your flow measurement, as low as 0.15 feet per second, and a low cost of ownership. Of course, you got to make sure on the limitation side that there's a certain amount of conductivity. Being that they're insertion sensors, they also have that same point velocity straight run requirement. And with the exception of the adjustable sensors, you still do require that signet fitting in addition to the sensor itself. Okay, so let's go a couple slides in here. This is going to be on our new full bore mags. These were just introduced last year. We brought them out with 1 inch, 2 inch, and 4 inch made of PVC. Again, no moving parts. These are based on the standard like full bore mags that are out in the market today, but it's all plastic. It makes it lighter in weight, roughly a third of the weight of a traditional metal magmeter. You do have straight run requirements for these, but they're greatly reduced, like we'll show you in the next slide or two. It's ideal for, you know, effluent lines, wellheads, skids, measuring chemistries and such. It does have a very high accuracy rating as compared with our other sensors in our product line, so it's going to be plus or minus 1%. We utilize these in bulk chemical distribution and batching. They do also offer reverse flow configuration, and that can be done very easily with the Bluetooth app that we have available. So no extra tools to buy. You can do it with either an Android or an iOS Apple type phone. And where the other magmeters of 25, 51, and 52, you bought one version that was either S3L or frequency, which was selectable during the wiring phase and jumpering it, or you buy a blind 4 to 20 unit. With this particular unit here, one part number gives you all those options. So you get the frequency or S3L in addition to the blind or the 4 to 20 output, which can also be selected as an active 4 to 20 or a passive 4 to 20 through the Bluetooth app. So the Bluetooth app actually allows you to do setup, actual readings, and then also troubleshooting and changing performance parameters all within that app.
One thing that I want to mention, Dave, is when I was reviewing the information on the FlotraMag, I was shocked to see, depending on the size, some of these units were actually had a price advantage over the insertion style magmeters that you sell. So I just want to point that out as far as when we look at the overall cost. It's really competitive.
No, absolutely, you're correct there. And this was something we did consciously on our part. You know, we're kind of newer on the full bore market with what we brought out. However, we're almost a year into it, and we've sold several hundred of these already, and the feedback has been phenomenal on this. We'll have the 1.5 inch and 3 inch versions out before end of the year, and then we intend on going with larger sizes as time goes on. But yeah, to your point, it is a very well-priced, low-cost mag for the performance that you do get out of it. So I mentioned earlier that we do have a reduced amount of upstream requirements. So these are again as low as 3 diameters upstream and 2 diameters downstream of the sensor, regardless of the obstruction. So whether it's a 90-degree elbow or a pump or throttle valve that's upstream of it, you can greatly reduce it now and fit these into those tight spots like skids and, you know, existing piping systems where you really can't add any more pipe. And you still maintain that 1% of reading accuracy, which again is traceable, and we provide certificates on that. So very good value for what you're getting there. Okay, so again, benefits of these, you got the no moving parts, you got a high degree of accuracy, being that there's no internal protruding parts, you have a 0 pressure drop. You do have a choice of wetted materials. Right now, the PVC comes with either titanium or Hastelloy pins, and which we've used in some aggressive applications already, as I mentioned on the bulk chemical. High turn down ratio, these go down as low as 0.07 feet per second. And of course, you can fit them into the tighter spots in your piping system, which provides a very low cost of ownership. Again, the limitation will be the minimum conductivity. Can be expensive, except in this case, so it's really an advantage to us against other full bore mags in the field. And metal versions on top of that can get chipped and can corrode in highly aggressive chemical applications. So, these limitations are actually a benefit on the Signet products. Okay, let's go next. Okay, which brings us to the last line of Signet products that we have. So we've talked about all installation type units where they're intrusive. You're going to have these applications where you can't get into the pipe. There might be high purity. This particular line of sensors with either fixed mounting, as we have with the two sensors on the right, or excuse me, on the left, and then portable with the two on the right, the battery operated version. So these are all time of flight. Next slide, please. And they're ultrasonic as opposed to Doppler ultrasonic. So these are time of flight ultrasonic. They do require clean liquids. So in a DI water application, again, where protrusion into the pipe is really not the preference, you can take and strap this onto the pipe. You use a coupling compound. It's about a 5-minute setup. If it's a portable type measurement, you can take your measurements and be on the go. No air bubbles, no solids are preferred in these types of applications. And it's simply a matter of, bouncing the sensor signal back and forth between the two transducers and taking the reading, and with the velocity having the effect on the signal, which then provides us with our ability to both display an output, give a 4 to 20. And in addition to that, these also have up to a 200 hertz output, so that you can not only run that 4 to 20 to a PLC, you can also run it, the frequency, to a standard Signet 9900 or 9950. Or if you want to run it to a PLC with a different building management system that would require Modbus, we also have those available on given styles of these sensors. Okay. Okay. I think we've got the next slide we can go to. All right. So they also require similar straight run requirements for up and downstream diameters. The nice thing about this is it's a lot easier to find it, especially if it's a temporary application where you're going to put it as more of a validation process. So you simply have to observe, again, the same kind of rules that we normally would have for insertion type sensors that are point velocity. A lot of times this would be used as proving sensors for other technologies. So again, very flexible installation with the exception of making sure you adhere to the up and downstream diameters here. Next, please.
Hey, Dave, before we move forward, since this is transit time, can these devices handle like solids or entrained air bubbles, things like that?
Yeah, good point. There are two different types of ultrasonic. One is like we're discussing here. This is more of a transit time of flight. And these units are dependent on clean liquids, no solids. Here we go. They can't handle too many air bubbles. So, for the DI application or pharmaceutical application or food and beverage, especially where, contact, can be an issue, this would be ideal for measuring the clean water. If there's solids, air bubbles, unfortunately, we don't have that technology. It probably would be a Doppler style technology that, would have to be utilized in those types of applications. So we've covered some of the benefits. There's no moving parts. They can be installed as portable or fixed. Again, no pressure drop or destruction of the medius because it's non-intrusive. Cost can be an issue. If that seems to be, make sure your process representative gets with us, and we'll do what we can to be competitive in those situations. They can be a higher degree of maintenance, especially with the coupling compound that's being utilized. On some of the sensors that we have today, we have gel pads that we use where it doesn't wear. And again, one of the other limitations would be the solids or bubbles. And then, of course, you can't have line pipes where there's two different densities on the piping material because that'll throw the readings off. Okay, I think this might be the last one, which a couple minutes over.
Yeah, so at this point, one, I want to thank everyone for attending. We did have interruptions, some audio problems and whatnot, so we definitely apologize for any inconvenience that caused you watching this presentation. But at this point, is there any questions that you have? Please share that with us. Dave, I don't see any questions.
Okay.
And if that's the case, again, I want to thank everybody for participating in this presentation. Dave Valere, I want to thank you for all your effort, and GF for being a great partner of Burt Process. And we look forward to
absolutely. Thank you for having me.
Working together and supporting our mutual customers with the best flow technology we can offer them. Thank you and have a great remainder of the day.
All right, thank you.